away from rivers and streams. And today, this same design continues to be part of the rural landscape, especially where there's no electricity to run water pumps. Production begins with a 100-ton punch press. Once activated, it cuts triangular shapes from galvanized steel sheets, each with a slot in the center. Each cutout will be a windmill sail. They'll need 18 for each wind wheel. Once stacked, they transfer the sail shapes to a rolling station. The roller curls the steel to an exact curvature, producing a slightly bowed shape, which will efficiently capture the wind. Next, a worker wraps a metal rib around each sail. He taps the sides until it fits. The rib has a tab that slots into the hole on the sail center, allowing the two parts to interlock. Bands fit through the ribs to assemble the sails in groups of 3. Next, a worker slides a metal loop over the guide wheel and drives the ends into holes in the gearbox. He rivets the ends to the gearbox, so they're firmly fixed. Next, he inserts the wind wheel hub and shaft into the main frame of the gearbox. He taps it into place. He then grinds the brake lever to shape it to the brake mechanism on the hub. This braking system is critical. It will stop the wind wheel from spinning out of control in high winds. He spins the hub and activates the brake several times to confirm that his machining is exact and that the brake system works perfectly. If it doesn't, he makes adjustments. Next, using a circular cutter, he carves grooves into steel blanks to shape the gears. The difference is obvious. He installs a set of these gears at the base of the metal loop and secures them with a metal pin. He checks their turning radius, then mates the larger set of gears to the smaller ones, ensuring that the teeth intermesh. This very substantial gear system will drive the guide wheel, creating the pumping action. 2 metal parts called pitman arms link the gears to the guide wheel. A steel pin holds everything together. As the gears turn, the guide wheel rolls up and down the loop to complete a pumping cycle. Next, he screws a series of thin metal rods to the hub. They're called wheel arms, and they hold the windmill sails. The wheel arms fit into pre-cut holes in the structure of the sail sections. He secures the assembly with nuts. Once all the sail sections have been mounted to the wheel arms, the windmill is ready for a spin. It's a test run to confirm the wind wheel and gears function flawlessly. It takes a crane to lift the 290-kilogram windmill to the top of its tower. Once in position, a worker guides the gearbox into the mast pipe. Once it's secure, they hoist the helmet. It's a cone-shaped metal cap that will protect the gears from the elements. He bolts it to the top of the gearbox. With that job done, the windmill is ready to pump. It should last decades, making pumping a breeze and providing water that is as free as the wind. Dragsters roar off the starting line in a cloud of smoke. Then it's a blur. Travelling at speeds of up to 515 kilometers an hour, these hot rods rip through a 400-meter racetrack in less than 4 seconds. It's why they need parachutes to slow down and come in for a safe landing. Blink a couple of times and the race is over. Packing an incredible 8,000 horsepower, a dragster is at least 50 times more powerful than an average car. with fat rear tyres for